Welcome to Algebra, Graphing Functions. In this lesson, we will dive deeper into how functions are displayed on a coordinate plane graph. Remember from an earlier lesson when we converted this linear function equation from standard form to slope-intercept form? The graph shows a line that represents this equation. All functions in the form y equals mx plus b, the slope-intercept form, are represented by a line on the graph. In this lesson, we will explore more about how this works. Let's take a closer look at this function and choose some values of x and see what values of y are generated. Here is a view of this graph in a really cool online graphing calculator called Desmos. You can find it at this URL, www.desmos.com/calculator. Once you enter an equation into Desmos, it shows the resulting line on the coordinate plane graph, and you can then generate a table of several of the points that are on the line. Each of these points represents an input value for x, the first number of the ordered pair for the point, and the y value, the result of evaluating the equation using the x value. For the x value -2, we substitute it into the equation, evaluate the right side expression with -4 times -2 becoming 8, the fraction 8/3 becoming 2.667, and then adding 2 to make 4.667, which matches the point showing on the graph. For the x value -1, we substitute it into the equation, evaluate the right side expression with -4 times -1 becoming 4, the fraction 4/3 becoming 1.333, and then adding 2 to make 3.333, which matches the next point showing on the graph. For the x value 0, we substitute, evaluate, with -4 times 0 becoming 0, the fraction 0/3 becoming 0, and then adding 2 to make 2, which matches the next point showing on the graph. Every point on the line works out this way, where the x value of the point is the input value into the function, and the resulting y value is the output, or result, of the function. Think of a function as a machine, process, or rule. For every input value, there is one and only one output value, and these ordered pairs of input and output values can be represented by an equation, and shown as a graph on the coordinate plane, a straight line, or a curve. The set of unique x values, the inputs, are referred to as independent values, and the x variable is called the independent variable. The set of resulting y values, the outputs, are referred to as dependent values, and so the y variable is called the dependent variable. Let's look at several examples. Watch as we enter an equation into Desmos, see the resulting line, create a sample table of points on the line, and then see how the coordinates match up. Here we input an equation y equals x plus 4. We go over and we create the table, and it gives us the values -2, 2, -1, 3, 0, 4, 1, 5, and 2, 6. We try another equation, y equals 3/4x minus 2. We create the table, and it gives us the values -2, -3.5, -1, -2.75, 0, -2, 1, -1.25, and 2, -0.5. Let's try another one. We input the equation y equals 3x. We create the table. We have -1, -3. Let's zoom out and look at the other points. -2, -6, 0, 0, 1, 3, and 2, 6. Let's try one more equation. Y equals -3/2x plus 2. We create the table, and we get the values -2, 5, -1, 3.5, 0, 2, 1, 0.5, and 2, -1. Now, you need to go to Desmos and try this yourself. This online tool will be available for you to use on all the exams for this course, including the final end-of-course exam. It is critical you know how to use this tool very well.